Hi, my name's Irrelevant, and sometime within the past week, I purchased this broken Jet City head. Sight unseen, and it's been modified. Let's see if I can get it going. The chassis is jammed because of some of these modifications, actually. It comes out better than it comes in. Yeah, look at that sexy chowder right there. It's because of these extra screws that they added. So I already know what's wrong with this thing. It was listed right in the ad. It was a blown power transformer. Here it is. Junk. Yeah, I tried testing on this thing. It's definitely not working properly. It consumes way too much current. I did, laboratory tests here. I did the thing where I bypassed the fuse to see if I could get anything out of it. You flick the switch on, your lights blink a little bit, which is alarming because they're on different breakers than my bench power here. And indeed, for the amount of current it was pulling, and I wasn't getting any real voltage readings off the secondary. So I don't know what its deal is, but I'm not even gonna bother with it. I have a specialty tool, a bypass fuse. You do not do this for regular use. This is something that I threw together for, bench testing things. But I have one of those ceramic fuses, and I have a piece of guitar string soldered across, and you see that brownness there? It was getting hot. And geez, that's gotta be at least 10 amps. The thing's rated for a 5 amp fuse. So I wonder if the modifications done to this have something to do with it. Some of them seem very kosher, but some of them are questionable. Seen here, we have a set of 3 switches, and I already kind of understand some of what it's doing. If we look at the Jet City schematic, it's got your typical 39K cold clipper that a lot of high gain amps are using these days, and that would be right here, R32. Now the cold clipper has been removed, and right here is your stock 39K. In the center position of the switch, this is an on-off-on switch, and if you flick it up, it appears to connect to a brown-red-red 13K. Putting that in parallel with that 39K is likely to reduce the value down to about 10K. So they're trying to get the Marshall JCM800 spec cold clipper going on here. And then if we flick it in the other direction, it's connected with a green-gray 5.9K, it looks like it. Presumably you put that in parallel with the stock cold clipper, and it's going to raise that value down much more significantly in and around the range you would usually see on a tube like this 1.8K, and that's indicative of some other high gain amps. I don't recall seeing a cold clipper in the 5150, and I know there's not one in the crate, so what that does for the distortion texture off the top of my head in this design, I'm not sure. Right here in the middle switch, it appears to be connected in some way, shape, or form to the EQ circuit. So that's going to have some effect on the EQing, maybe a mid-shift kind of thing. It appears to add a resistor and a different capacitor. Actually, it replaces C17. What's C17 in this circuit? The bass. Yeah, if you change the value of that guy, it can really have a huge effect on your slopes. Well, not your slopes. I'm not sure what to call it. I'm having difficulty reading the value with all the gook everywhere. It looks like that's the stock C17 right there, and then it adds this and some resistance. So I'm not going to bother reverse engineering it. Lastly, over here, this switch position is over R23. And R23 is the cathode resistor and the cathode follower. The resistor itself appears to still be stock. It's hiding underneath there, but it adds a capacitor, a 1K resistor, and clipping diodes? Really? Yeah, it adds some diodes. We have a capacitor and a resistor in series, and then that's in series with this diode cluster. We have 3 LEDs. So it appears to be adding diode clipping right in and around here after all the preamp stages and before the EQ. So that's the thing. I got this to scrap it and use the chassis to build something else into, but I'm curious as what this sounds like. Now, among the other mods, they have gone ahead and added, a whole nother power supply to it. Seen here is a whole nother transformer added to the circuit, a little Hammond. It's a 6-volt transformer. And then this big chunky is just, there's a bridge rectifier and a whole bunch of capacitance. Like there are 5 2200 UF capacitors in parallel here. That's a lot of filtering for what they're doing. Is they've run this wire all the way down and they've attached it to the heater of the first 2 tubes. And if you look closer in here, they've actually cut the traces on the board so the AC heaters are no longer feeding this way. Now, one of the other modifications that I found also in the power supply circuit, well, this guy here attaches to one side of the heater circuit and then they had it tied to ground. To the best of my knowledge, that's not how we ground out DC heaters. DC heaters will use an artificial center tap, much like the AC heaters might if they don't have a center tap, which the stock heater circuit did. And I found that center tap connected to the balance resistors going across the filtering capacitors. That'd be right here. So they took that center tap and they tied it over to here. Now I know what they were trying to do. This is a mod I'm familiar with. It raises the voltage potential of the heater circuit in respect to the main power supply voltage so that it's better on the cathodes. Like in electrical design, all the various components in a triode need to be a certain voltage potential away from each other. And one conflict that happens in tubes is you got the DC heaters running off 6 volts and they're very close to the cathode in the tube because that's what they heat up, and that cathode could be at several hundred volts, and so that huge variance is known to, or said to, wear out the tubes prematurely. You'd get more life out of them if those heaters had a higher voltage potential to them. So they take part of the power supply and add it to part of the heater circuit so that it doesn't affect the voltage that the heaters see, but it still has some of that higher voltage pulsing through the circuit, bringing its potential to the rest of the circuit up, and well, that's supposed to help things along. But regardless of the good ideas and the good intentions of that mod, no amp builders ever do it. Not any of the big name brands. Now, we can all argue that the corporate brands, you know, they don't care about tube life. The more money you spend on tubes, the better it is for them. So the more discerning amp user might like that mod, but the problem is, I don't know if it was implemented correctly in this amp. And I'm questioning if that's the reason why we saw a premature failure of the power transformer. Now, I did do some Googling, and indeed, there is suggestions that power supply failure in this amp isn't uncommon. I've seen other reports of it online, so maybe it's just coincidence. I didn't like that mod. I'm not going to be putting it back into there. So at the end of the day, we need a power supply transformer for this. So I had to go and pull one out of another amp. This one came out of a Trainer Voicemaster, and it's about the right range that we're going to need and should be able to accommodate this. It's just a question of getting it shoehorned onto this chassis so that we can get power to it. Let's see if the holes even line up. Two of the holes line up. So let's have at her then. Okay, the grommets mostly line up. This wire is fished through. Come on now. Oh, it's hooked around. Start swearing at this guy like the Christmas story dad. What's the problem, bud? It's not even that hard of a task. I believe I got the wires through. Now let's see if I can flip this without dropping the tranny out. How's that look? So 2 of the holes line up on this side, this one not at all. But you know, if we can get the bolts to fit through, that should be good enough to appease the testing purposes. These are some thick screws they got there. The holes in the transformer are smaller than the bolts here, so I'll just use some of the nuts and bolts originally associated with this transformer in the other chassis. They're ugly, but they should work. This is gonna be a contortion, isn't it? This is gonna take a while. Perseverance perseveres. Except we celebrate prematurely because I still have to manipulate all this. Okay, that's 2 holes into place. Now we have a problem. This transformer was a tripod to begin with, so it's missing a mount point here. And then this one, well, a little bit of a deviation there, bud. Let's see if there's a way I can accommodate that. I'll have to consult the hardware department. Oh, there's a piece of vintage steel. All right, she ain't pretty, but she works. A good old-fashioned holder down, or try not to cut yourself on these frigging self-tapping screws sticking through the chassis. All right, transformer's mounted. Let's see if we can get it wired up. Now I gotta kind of remember how this all fits together. We got some ground points there, a bias point, separate bias circuit. Ooh, rebiasing this guy's gonna be fun because I'm seeing a general lack of current sense resistors. They don't show up in the schematic. You know, they have an adjustable bias potentiometer right here, but how are you supposed to test on the bias? Oh, I guess we use our specialty tool. Now, one thing about this guy is it has a separate 12 volt power supply right about here to fire the relay switching. So how we're gonna get that to work? We're gonna need another power supply. And we might have the problem, these leads not quite reaching, right? Well, I need to do some solder sucking to prep these holes. Okay. Okay, I think I got everything mostly ready. Now the main power input is off this switch. So the main red leads from the power transformer will just solder onto this switch here. Oh boy, come on now. Don't let me down. You're sinking a lot of heat, that's not good. Ooh, combining fresh solder with ROS compliant solder. It looks very... The crappy solid copper wire hookup wire Buddy used. Does it even have a decent insulation rating? Solid copper wire is like something I might have done back in my very novice days. This ground connection here, I don't know what to do with that right now. Blue wires are bias. Gotta get one of these to ground. Is it gonna reach? Oh, it's just gonna reach, bud. That's good. Just. Is the center tap for the heater gonna reach? Yeah, it will. Let's get the center tap for the heater in there. And then the tap for the bias. Thing needs a little bit of a squeeze. Check this technique out. Heat it up, heat it up, heat it up, heat it up. Squeeze it, squeeze it. Oh yeah. Fingers used to getting burned. Now let's give them some solder. Okay, now we just have to get these heater connections over here that are kinda in the way. And they're ugly AF. I think these are gonna be kinda half-assed into there. The heater wire connections are ugly but effective. And PL1 and PL2, what are those? Oh, pilot light. If it had a DC pilot light. Okay, it doesn't though, which sucks because the pilot light that is on here sucks. All right, so finally the two blacks for the mains. What do we have? We got the blue and brown going into the switch. And actually they go into the top of the switch and then this black and white coming out of the switch. Black, white, brown, blue. So we just got to take these guys and splice them onto here. Probably better to do that with wire nuts than actual solder. Oh, use some solder anyway. We'll just cover these up. They're soldered, but we'll use wire nuts to insulate them. Now the switching circuit, 12 volts. Now I believe the amp can be modified to run off 6 volts. So there's our input there, and then it has a little bit of rectification, and then a dropping resistor. Now those relays, they might be 12 volt relays actually. They have a part number that says 12. So maybe that is just biasing. There's a chance we can manipulate on this dropper in order to get it to work off 6 volts or something else. We just would have to isolate this connection from ground here. I can't tell on this circuit on the board if it's grounded other than on the chassis itself here with the foot switch. So we're not gonna bother with switching right now. We're gonna see if this works because, well, it's hooked up now. Let's do an initial function test. We're gonna put a proper fuse back into place. It actually came with a spare fuse. How do you like that? Let's get an IEC plugged in. All right, wish me luck. Transformer hums, but it hums normally. I'm not detecting any foul play. Let's just double check. We got some correct voltages flowing through this guy. 330, okay. The rest of it I should be able to detect through the chassis ground, the bias, 60 volts, and these PLs should give me about 3 or 4 volts each. Okay, let's put some tubes into it. That's where stuff gets slightly annoying. It came with these rather fresh looking 6L6JJs. Is my testing tool actually gonna fit in here? They got wider holes. Okay, it will. It came with 3 Chinese, newer ones. That's one great thing, the tubes looked fresh in this. There was a Sovtech WA in the phase inverter. Not sure if that's my first choice for a phase inverter. And then it had an ECC83S in V1. It also came with but 2 tube shields. All right, now let's just test the milliamps on the tubes here. See where they sit. milliamps. We are getting nothing on the tubes. That or I've hooked something up wrong. Oh, wait. Oh, this might need a center tap transformer. It shows a full wave rectifier here, not a bridged. Oof, oof, oof. That means we have to make changes to the power supply circuit in order to get this thing running. Hote, back to the drawing board. Okay, yeah, we're showing a wave rectifier when we need a bridge rectifier. Oh, that's wonderful. We're gonna have to whip something up. Okay, so what did I do here? You probably wanna know what I did here. Now, if we look, we already have half of the bridge going this way. We just need the other 2 diodes. So I kinda, pretty much half-assedly added a pair of diodes onto there and then, attached them to ground. It occurred to me that the original transformer has a bias tap, not a whole another bias coil. So that was taking up the space that would have normally been the center tap. Well, here's hoping I didn't mess that up now. Watch, it's a whole different story now. Do ourselves a quick voltage test. That's ground potential now. And the bottom of R2 here should be 460 volts. Good, we have power. Now, let's put in our tubes and check our bias. Oh, we're getting readings. Ignore the negative, it's just because I have these leads connected backwards. I'm hoping it terminates to about 45 milliamps. Oh, actually 27. She's running cold, bud. She's running cold. Okay, let's flip her over and get it adjusted. It's that guy right there. How the heck do we get a screwdriver in there? Oh, it's very blunt. It's very, very blunt. It's like it doesn't even make sense. Oh wait, I'm actually managing to turn it. Oh, 50, overshot it. Actually, it's 46. I wish my calculator was in reach. Oh, it's not. I'm gonna have to use the computer. 30 watt tubes divided by 460 known voltages, 65 times typical bias 0.7. 45, yeah, that's exactly what I guessed. Come on now, just give me a touch less. There we go, 45.7. We'll call it good there. Yeah, it even says 45.65 on the calculations. So let's call it good, sir. Let's call it good. Let's remove this tool while this tube is still not too hot. All right, sir, give us a rotato. Hote, says. Hotes. Just a rough test in here. Oh, I hear something out the speakers. We should be in overdrive mode. No? Crunch mode? We're getting no sound. Overdrive hums. We're definitely on the overdrive channel. The hum suggests we have output. We have no heaters on the first 2 tubes. Well then, that might explain things. All right, let's flip her back over and take another peep. So, yes, we have a situation where this guy has been screwed with a lot. So, we got this DC heater line running here, running to this power supply right here, running to this transformer that I know works. It should be getting power here. And where's its other source of power? Oh, it has to do with phasing. Okay. So basically, the way they wired this transformer up stupid. So brown is hot, which goes to the hot lead. This is neutral. They soldered this to the 2 hot lines, technically. But, if I just take the white and put it on hot, which is not the way the color code should be, and then put the black on the neutral, it doesn't care for the power transformer. It's not going to care which one's which. Actually, the transformers, they're bipolar, so they don't really care at all. So now it should work. I wired it up as per industry spec color code without paying attention to how that transformer was actually hooked up. Now we should get heaters. We should get all the things. And maybe not a whole heck of a lot of catastrophic noise. There it is. That's at 50% gain. This is definitely a metal amp. Past 5 gain, it just gets sloppy. That's a lot of hum. Because those DC heaters aren't implemented correctly. All right, now that we know this works, I'm going to get that foot switching working because I believe that some of these mods are to accommodate the crunch channel. And then I'm gonna set up the mic and then we'll demo what this thing sounds like. Be right back. All right, so here's what I've gone and done. This is a 10 volt transformer that I use for testing other transformers, and I have spliced it in to the input for the foot switching circuit, and it seems to have just enough jam. Don't know if you can hear that, but the relays are indeed firing. We could always reduce the value of this resistor to compensate. It's dropping about 2.5 volts, so them puppers are getting about 7.5 volts. Meanwhile, hopefully to solve some of the hum issues using a method that I'm familiar with, here on the half-hour DC power supply, we got a couple 220k resistors and a 0.01 capacitor. And you see how this works, if you can look at my drawing, and is we got our plus coming out here, our negative coming out here, and then, well, these two scribbles right here are the resistors, 220k, and then they kind of go together like an artificial center tap. They go through the capacitor and then they go through ground. That's how I've done hum canceling for DC power supplies before in the past, and it seemed to work fine. Because these are brass, I just soldered it onto here, and hopefully once I bolt this to the chassis, I'll get good enough continuity to ground to solve that problem. Should I ream on this first? We can. Buddy didn't have fancy tools like that, we can tell. This one right here, we want to make sure it's good and tight because that's the ground point. All right, let's check real quick, see our ground continuity. We're set to the lowest ohm mode. Ground's going to be on this guy here, and then let's touch it to, yeah, good. That should work now. Hopefully this thing's a lot quieter. All right, so we're on overdrive. It's at 5. All these switches, we're just going to turn them off. Everything's halfway. Let's see what this thing can do. So this has a depth mod in it. Wonder what that's gonna do. Not a whole hell of a lot that I can tell. I'm not hearing a lot of functionality out of that EQ switch, but I guess it does something. Cold clipper, I wish I could remember which function was what. Now, one thing that I was finding is I do believe if I go to the crunch channel, that's going to better accommodate some of these mods. Definitely less gain. Specifically the clipping diodes. It's got a little bit of Jubilee effect to it. You notice it's a huge change in the volume. Okay, let's go back to the overdrive channel. Well, it certainly has an interesting sound to it. Not sure if I like it. It has like this interesting tonal quality in the mids that, you know, does sound like it'll roar a bit. Then it has this kind of squishy like this weird crunch texture in the high end, but it's dirty. It's not clean and tight. It's very sloppy. And I'm not sure if the original amp would have sounded anything like this or if it's been messed with a lot. Or maybe the voltages on this transformer are just not accommodating. She's not heating up. Like, assuming the voltages that come out of that transformer, the stock transformer, does it say? 350, 350. That's what this guy was doing. Or was it 340? Or was it 330? I think it was 330. I don't know that 10 volts on the preamp 2 is going to make that whole heck of a lot of a difference. We could try heating them up a bit and see what happens. But, I'm just kind of rambling on at this point. I don't know, man. I don't know. This is interesting. We got her running again, but she's got issues. She needs a bit extra power there to actually do anything. Or we got a mod on that foot switch circuit. I believe, other than a little bit of sputter, yeah, we managed to get rid of the hum. That obnoxious hum from the DC supply. Maybe it was quieter than this before because, you know, he had some interesting ideas. Yeah, well, I don't know, buds. I hope you enjoyed this. I'm not 100% sure what I'm going to do with this guy yet, but stay tuned to find out.